Good afternoon, everyone, and welcome to Tech Talk Tuesday here at Treadwell. Thank you all for joining. If you've joined us previously, welcome back. And if you're joining us for the first time, welcome. Appreciate your time. Appreciate you joining these sessions, which we hold every 2 weeks, typically on a Tuesday, occasionally on a Thursday at this time, which is 1:30 here in New South Wales. We run through a variety of things related to either design standards or FRP, design, fabrication, repairs, all that sort of stuff. So before we get started, on our website under Resource Centre or on our YouTube channel, you can see past recordings of these sessions, and we'll have a Q&A session at the end, but I've got the Q&A window open now, so if you think of something as we're going, feel free to drop it on the chat. And lastly, any feedback is welcome, good, bad, or ugly. If this was worth joining, we'd love to know. If it was a waste of time, we'd like to know that too. And if there's any topics you'd like us to cover, feel free to drop that through as a suggestion. A lot of the topics we do cover are from suggestions from people who hop on board these sessions. So always looking for suggestions. Now, today we're going to have a bit of a look at FRP fabrication and repair. Now, it's not going to be exhaustive, and we'll try and keep it brief because we're conscious of your time, but there's a fabrication repair manual on our website under Resource Centre, and then the tab Technical Installation. You can download that. That's the basis for what we're going to talk about today, but has a lot more detail in it around cutting, drilling, repair, etc. So today's high level, but hopefully gives a bit of clarity around the correct procedures for cutting, drilling, and so on, FRP, and why that's important to know, and what we can do to get the best possible performance out of the product. So, by way of a quick intro, why? Obviously, correct cutting procedures, correct drilling procedures will reduce the fabrication time by using the correct equipment, but also make sure your structure is going to have the best possible lifespan once it's installed. So today we're going to touch on cutting, drilling, some basic detail on bolted connections, and then resin sealing, so resealing of cut edges or drilled holes, and why that's best practice or why that's beneficial to do. Now, goes without saying, but just a bit of housekeeping. Obviously, please ensure you use the correct PPE, especially when you're using power tools, safety glasses, gloves, and so on. Make sure you keep yourself safe when you're using power tools. So, a bit of a quick list of commonly used equipment. It's on your guide. It's not exhaustive, but a bit of a list. Gloves, a respirator or a P2 dust mask, hearing protection of some form, measuring and marking gear, and then your appropriate power tools, so drills, grinders, saws, whatever you choose to use, impact driver or rattle gun, sockets and spanners, and clamps as is needed. Bit of detail around cutting. So there's a few ways to cut FRP. The way we typically run in the factory is with a water jet or CNC gear. That's not a luxury you've got on site. So what we're discussing today is more around site cutting. Best way you can cut FRP is with a diamond blade. Now, a few diamond blades are available. We sell blades, which we get made for us. They're not cheap. Be totally upfront. However, they do have more diamond coating on them than any other blade on the market, which is why we get them made for our own use. If you're only doing a few cuts, probably not great value. If you're looking to do a lot of FRP fabrication, probably worth getting in touch and having a look at them. The best way to cut FRP, this is grading, structural sections, handrail tube, etc., is a diamond blade. Now, that might be on a circular saw like you see here. It could be on a drop saw. Good way to do handrail and small structural profiles and so on. Could be on a grinder or a jigsaw or a Cipro if you're looking to do small, more intricate cutting. A lot of people ask about using a carbide tip saw like a timber blade. Now, it will cut the product. However, there's a couple of things. Firstly, it doesn't last very long, so the glass content of the FRP takes the edge off the teeth very quickly, you'll get perhaps half a dozen cuts out of the blade, which is not good life. The second thing is that it leaves a rougher sort of finish. So you have burrs or a bit of a jagged looking edge on the FRP, which is visual, but if you want the best possible appearance, diamond blade gives you a better finish. On diamond blades, everyone's seen, no doubt, your typical segmented concrete cutting blade. That will cut, but it will leave a bit of a bird finish similar to the carbide tip blade we just mentioned. If you get a continuous rim blade or a turbo blade, typically used for tiles, that'll give you a nice, cleaner finish without a lot of the burring and jagged edges that you get by using either a carbide tip saw or a segmented concrete blade. Now, we mentioned water jet. We offer a cutting service, obviously, here at Treadwell. If you've got a water jet, you can obviously use that to cut FRP, or if you know someone with a water jet, they can also use it to cut FRP. It does a nice job. Use a little bit of garnet, and you get a nice, clean, smooth, burr-free edge. Also, obviously, has the added benefit of dust control. Now, just on dust control, since we're on sawing and cutting, where we typically would generate some dust, a couple of ways to deal with that. One is wet cutting. If you've got water on site and you've got a means of draining the water and so on, then that's a good option. If that's not an option, then vacuum dust extraction is typically what we see done. Portable vacuum cleaner or a similar sort of setup to what you see for concrete cutting indoors. And that is a good solution to dust management for FRP. On drilling, would recommend typical tungsten carbide bits to be used. We also offer drill bits, which we get custom made. They're a bit of a cross between a brad point bit, which you normally use for timber, but they do have a decent layer of tungsten carbide on the end. They start life as a masonry bit, so we get those made. We have them available to purchase. Once again, they are a handmade bit. They're not cheap, but they do give you the best possible lifespan for if you've got a reasonable amount of product to cut or to drill in this instance, good option. If you don't, tungsten carbide bit will give you the best life. A standard high-speed steel bit will work, but just be prepared to sharpen it frequently. Once again, a bit like the timber blades we discussed before, the glass in the product will take the edge off it quite quickly, so you need to just make sure it stays sharp. Drilling speeds, similar to hardwood, not typically recommended to use any sort of lubricant or cutting fluid because that will just hold the FRP dust, which is somewhat counterproductive. However, you can, once again, wet cutting, if you wanted to use a core drill or something like that drills wet, then that's also an option. But an oil or grease typically is counterproductive. Now, on connections, typically FRP connections are bolted connections. The product's designed to be heat stable, so it's a thermoset resin. It doesn't melt, which means we can't plastic weld like we would with, say, a poly pipe or something like that. So that means we're using bolted connections. Now, typically we're using standard fixing, so that would be stainless, hot dip gal, and so on. FRP fixings are available, but there's a bit of a potential challenge with using them, which is very simply if you've got, and this is a rule of thumb, so this is not by any means a definitive guide to swapping them out. This is just to show an example. If you had, say, an M16 stainless bolt, you might need an M24 FRP fixing. Now, that's fine if there's the physical, the space, the real estate, if you like, to do that. If there's not, then that's obviously prohibitive. So typically, most often connections are stainless or hot dip gal fixings. In areas where there's vibration concerns, Loctite can be used. We would always recommend using nylock nuts. Anything we supply would typically be with a nylock nut the idea of what we do is obviously low maintenance, so boosting fixings kind of is a bit counterproductive. Where stainless fixings are used, and this is often overlooked, especially when we're not familiar with or used to using stainless, an anti-seize or at least a moly-based grease. Just a light smear on the threads will help you prevent galling or binding, especially if you're using power tools. Uh, Nothing worse than having a nut or bolt gall and seize on you when you're trying to get the structure built and having to cut it out or remove it and replace it. So anti-seize or at least some sort of moly-based grease will prevent that. Um, and just a note, you can get from most tool supplier places, you can get a spray anti-seize rather than the old anti-seize in the pot, like a tub of grease. You can get a spray anti-seize, which I'd say from experience is probably not quite as good, but it definitely does do the job, and it's a lot easier to apply than having a tub of anti-seize and the mess that comes along with that. Now, lastly, we would suggest on all FRP connections that you use a flat washer on both sides. So under the head of the bolt and underneath the nut, flat washer on both sides of the connection. Just by way of a little example, um, this is typical bolt tightening torque. All bolted connections should be snug tied and then quarter turned um, as a general rule, so that we don't crush, especially hollow sections. Where we're using square hollow, rectangular hollow, typically we'd need an anti-crush instrument. Not always, but generally. And obviously some basic tightening or process matters. Tightening should be done at a uniform rate. That's pretty straightforward stuff. Torque values will vary depending on the type and diameter and application of the fastener. You can see this table we've got here on the left. And then oversized washers will also assist. And by oversized, we mean the outside diameter of that washer being 2.5 times the nominal bolt size and 4 mil thick. So as you can see here from this table, and this table is available in our structural design guide, we can significantly increase the torque capacity of the FRP section by going to an oversized washer. Now, just before we wind up, quick discussion around resealing FRP. So it's something we often see overlooked, and to be clear, it's not going to suddenly lead to catastrophic failure or something like that of your product. But we're going to FRP, we want the best possible life for our structure. That's typically why we're going to FRP. So where this is necessary is if you've cut, especially cut, but also ideally drilled an FRP section in the field, typically a brush on, potentially a spray on if you've got the right equipment, but typically a brush on type treatment should be applied to the cut surface, so the cut end or the exposed FRP around the hole that you've just drilled or punched. And the reason for that is FRP behaves a bit like timber where it's exposed to moisture. If you've got an end grain of timber, you'll know that often there's a concern around moisture tracking into that, which swells it. And it's a downhill journey from there. FRP is similar. So if we've got an exposed end, we can see moisture creep in and prematurely age the product. We can also see in high chemical areas, sometimes the glass in the product exposed to some form of corrosion or chemical attack. We want to prevent that. So by just resealing your cut edges, and as I said, it's a typically a brush on treatment. It's a two-part, mix your resin, your hardener, and brush it on. It also helps aesthetically. Anyone here who's worked with FRP will know if you've got, say, a dark grey product, once you cut it, that colour, the cut edge has a lighter colour, so more of a duller, lighter colour. If you brush on the resin sealant, then that'll redarken and bring that original appearance back to the cut edge. So from a longevity perspective, definitely recommended, but also from a visual perspective, it does make the cut edge look a lot neater and more like the appearance of the original product rather than having the sort of lighter, more chalky appearance. So we sell sealer kits, and they're a V series or a vinyl ester resin that we sell. Um, some other hardware stores like Bunnings will sell a standard polyester resin, which you can also use, especially where the product's not in a high corrosion environment. Um, so things like public structures, boardwalks, and those sort of things, you could just simply use a product available from a hardware store. Otherwise, we have available, and you're welcome to include in your FRP orders a sealer kit from us here at Trevor, which is a vinyl ester resin. Brief discussion. We're out of time. I hope this would be a shorter webinar than usual, but no such luck. So just a very brief discussion on handling FRP. A couple of benefits. One, we've reduced the weight, and the product typically doesn't have the sharp edges that you might see with punched steel or something like that. But also, there's no hot work from cutting or drilling and so on. So we're not generating sparks. It means you don't need a hot work permit, and there's not the fire hazard on site that we sometimes see. And lucky last, the product is typically lighter weight, so once again, reduce heavy lifting. Now, I mentioned this at the start. On our website, under Resource Centre and then Technical and Installation, you can download this guide here. This is a fabrication repair guide that we publish. A lot more detail than what we covered today, but today was just a brief overview. We'll stay on board for a couple of minutes. If anyone's got any questions, we'll answer what we can here, or we'll take it on notice. Feel free to drop us an email, hello@treadwellgroup.com.au, or give us a call, 1-800-246-800 for Australia and 0800-244-600 for New Zealand. Happy to arrange a site visit, happy to have a chat around your projects and fabrication practices or anything else related to FRP. Always available for a chat. The technical team and our design teams are always really ready and waiting to assist however we can. So 1:47 here in New South Wales. Stay on board for a minute or so. If anyone's got any questions, feel free to drop on the chat. Otherwise, if you'd like to discuss something in more detail, feel free to drop us an email, hello@treadwellgroup.com.au, and we'll set up a time to pop in face to face or set up a Teams or a Zoom discussion and go through whatever you'd like to go through. Question here from Daryl. Can structural repairs be undertaken by any trade, or do they need to have specialist skills? Look, I would say no. There's not really a specialist skill set for most repairs. Anyone who's carpenter or boilermaker sort of background, who's familiar with power tools and tape measures and all that sort of stuff, reading drawings, definitely from a fabrication perspective, no worries. From a repair perspective, depending on what the repair is, like an example, we had a structure we supplied for a client quite some time back. It's a full FRP structure, columns, beams, grating, handrail, etc. It's about 25 metres long, I think, and 7 or 8 metres high. Now, one of the columns of the structure got hit by a forklift, which did result in some damage. But that repair was undertaken by a fiberglasser, so someone with fiberglassing experience, and there was just a on-site repair procedure which we put together and provided, cleaning up a bit the damage. There was a couple of cracks in the section which just chase out a little bit like concrete, and then they're filled, and then we laminated over a skin, if you like. So that uses glass and resin. We can help someone with the skill set to do that if needed, if that skill set isn't available. This client had fiberglasses on site anyway as part of their other operations. So anyone with sort of boat building or that sort of background has the necessary skills. Otherwise, we're happy to help with some training if need be. So sorry, it's a bit of a roundabout answer to your question. But for basic repairs and so on, no. For more complex repairs, there would be some skills required. Do we provide on-site repair services? Not generally. However, we would offer on-site support by way of training and so on. If there was a crew that wasn't familiar with the product, we could send someone out to help them with, a few hours or a day of training. Typically, typically, from a labour perspective or an install perspective, we don't typically get involved in install. As a general rule, there are exceptions to that, but we do offer on-site support if there's some training that needs to be done or something. I don't know whether that makes sense, Darryl. Question that's coming from, I think, Juliet. If steel gratings cut, banding can be used to support the unsupported edges. Is there something similar for FRP repair? Um, so FRP can be rebanded, yes. However, rebanding is purely a visual. So rebanding is not needed from a structural perspective for FRP, whether that, you mentioned I-bar grating, that applies to any FRP grating product, whether it's a regular square mesh or whether it's the I-bar, T-bar type product. Rebanding is able to be done. If you're looking to do a pipe penetration, you could put a kick plate or a collar around that, for example, or you could just put a bar on, which gives you a nice, much more visually pleasing edge. However, it is a visual, it's a visual only, or an aesthetic only. It doesn't, it's not necessary from a structural perspective, unlike steel, where typically you'd want to reband and weld on a band from a structural perspective to provide support to the unsupported edge. Wouldn't Doesn't add anything structurally. It's not typically necessary to do that on FRP, but if you're looking for a visual, that nice visual finish, then yes, it is absolutely able to be done. And on that note, we can offer it as a part of our cutting and fabrication service, be done here in the factory, or we can supply what you need to do it on site. The housing attached, it's an adhesive and a mechanical stainless steel screw. So glue and screw. Yeah. Look, no worries. Looks like that's the end of our questions. So thank you all for joining. Appreciate your input and your interest, your support, and appreciate the engagement with the questions. If you think of something else or a question comes up, or you've got any feedback, or you would like to make a suggestion for a future webinar, feel free to do that by sending an email to hello@treadwellgroup.com.au. Always interested, always looking for more ideas for content, and always happy to have a discussion around a project or anything else. So thanks again for joining, and we'll see you again in 2 weeks. Cheers.